Hello everyone, welcome to question session 4 for fluid mechanics. In this chapter, we will solve our questions on buoyancy and flotation. Okay, so let's discuss some important points first. So according to your Archimedes principle, your buoyant force Fb is equal to rho of fluid times of g times of v of volume of fluid displaced is equal to your rho of body times g times of v of body. Okay, only then will your body float, and this is called your law of flotation or flotation principle. Okay, now as I have discussed earlier, your okay, but before that let me mention one more point here, that is your metacentric height gm is given by bm, that is metacentric radius minus bg, and your bm value is I minimum one volume of fluid displaced, okay, minus bg we calculate from your geometry. Okay, now uh, for stability, this is your case for stability of your submerged and floating bodies. Okay, and your time period of the flotation is given by 2 pi of root k square by g times of gm. Okay, so these here are some important points. So let's start with this question. So in here, consider a large cubic ice block floating in the seawater. The specific gravities of ice and seawater are this and this, or respectively. If 25 centimeter high portion of the ice blocks remain extended above the surface of the water, determine the height of the ice block below the surface. So from Archimedes principle, we know that for flotation, or we can also say for flotation principle, flotation, your weight is equal to buoyant force, or buoyant force is equal to weight. Okay, so weight of this ice cube will be density of ice g into volume of the ice. Volume of ice is equal to density of c into g into volume of submerged or fluid displaced. Okay, now density of ice is given as your 950, specific gravity of ice is 9.92, so 920 into g into volume of ice is equal to, so this is a cubical block, so 25 plus h is at the side, and the side q of the side is your volume. Okay, is equal to density of c, that is 1025 into g into volume of fluid displaced will be your cubical volume of dimension h, a cuboidal volume of dimension h, and depth and width of h plus 25, so h into h plus 25 square. Okay, sorry, one more thing, okay, so let's calculate the value of h in meter here, centimeter here. Okay, so this is correct. Okay, it's like this. Okay, now so we have to solve this to calculate the value of h. So let's substitute the values here. So we substitute the values here, so it is like g will cancel out g here, and this will become 25 plus h cube is equal to 1025 divided by 920 into h times of h plus 25 square. So like this square, this term will cancel out, this here and here, like only power 1 will remain. So 25 plus h is equal to 1025 divided by 920. This is equal to your 1.114 times of H. Okay, now from here we can calculate your value of H, which is equal to your H is equal to 219.3 centimeter. Okay, so this is the height of ice block below the water surface. Okay, now we'll move to the next question. So in this question, the uniform block of steel have Sg of 7.85, float at a Merkel interface as shown in the figure. What is the ratio of distance A and B? Okay, so if I talk about again Archimedes principle, so what I can say that your bind force will be equal to weight. Okay, now bind force for like you can write for in two parts, for part 1 and part 2, both are steel blocks. Okay, let's say that A is the area, cross section area of the steel block. Okay, so we can write bind force is equal to rho of water times G times of volume, that is A times of capital A. Okay, is equal plus rho of mercury times G times B times of A. Okay, this will be equal to 8, that is your uh, density of steel into G into volume, that is A plus B times area A. Okay, so density of water is 1000 times of A plus 13560 times of your B is equal to density of steel is times of A plus B. Okay, so from here I can write like 13560 minus 7850. Okay, so this is 5710 times of B is equal to 6850 times of A. Okay, divide by, so we have obtained A by B, or B by A is equal to 1.2. Okay, okay, so this is the ratio of A by B required for a steel block to float it at the interface. Okay, now next question. uh, Hull of boat has volume of this, and the total mass of the boat when empty is 8560 kgs. Determine how much load the boat can carry without sinking. Okay, so we can say that weight of body W is equal to 8560 plus mass. Let's say mass is your additional weight, mass is your load. Okay, times of G, this is the weight. And from your Archimedes principle, we know that your buoyant force is equal to weight of the body. So in case of lake water, we can say that buoyant force is equal to weight. So buoyant force is equal to density of the your volume, density of water, density of water, G times of volume. Volume is of water displaced or fluid displaced, it equal to weight, that is 8560 plus m times of g. Okay, now g will cancel out, so density of water is 1000, okay, into volume of fluid displaced for maximum load. Determine the how much load does band carry without sinking. So for maximum load, your volume of fluid displaced should be equal to your volume of hull. Okay, 180 meter cube is equal to 8560 plus m. So let's solve this. This is your 180,000 minus 8560. Okay, so your mass, total amount of mass that can be loaded in case of your plain water is your 171.44 tons. Okay, and 1 ton is equal to 1000 kgs here. Okay, okay, now for B part, it is, since it is sea water, so again I will write here FB is equal to W. Okay, now your FB is rho of ice water, that is 1030 times of G times the volume displaced is 180. Okay, is equal to 8560 plus m times of G. Okay, so from here we have obtained 180. Okay, minus 8560, m is equal to 176.8 per ton. Okay, okay, or tons. So this is your for lake water, this is for your sea water. I hope you get this solution. Now we will move to our next question. So in this question, so inverted cone is placed in a water tank. If the weight of the cone is, so it is mentioned that weight of the cone is 16.5 Newton. What is the tensile force on the cord connecting the cone at the bottom of the tank? Okay, but before that, let's like we can say what we can say here. Like one more thing for certain is that your uh, like what were the different forces acting on the cone if I talk about. So one is the weight of the cone, second is your buoyant force due to water, and third is the tension in the cord. Okay, so let me place it here. So this is your CG. Okay, so this is point G. Okay, this is your weight. Okay, now at the center, so this is at this line there will be your water surface line. Okay, water surface line. Okay, so at this point, let's say is the center of buoyancy B. Okay, and this is your FB, buoyant force. Okay, and here it will be like tension in the cord. Okay, this will be acting. Now if I want to calculate, so let me write here your equilibrium equation first. For equilibrium, what would be the your case? For we can say that weight plus buoyant force. Now there are two cases possible. First is either your weight of this cone is greater than the FV, then your tension will be in upper direction. Okay, tension can be in your upward direction. Okay, or can be in, or if your buoyant force is greater than that of W, so then your tension will be in lower direction. I think you should understood is this point. Okay, But since this code is like taught here, okay, and your body is floating upside, so we can say for sure that your buoyant force is greater than that of weight. Okay, only such that is only then it will be possible for certain amount of this metal block to be remaining outside. Okay, so your tension should be always be here in downward direction. I hope you get this point. Okay, so from here we can write W minus FB plus T is equal to 0. Okay, so I can say that my tension is equal to FB minus W. Okay, so let's substitute the values here. So if I want to write your value of FB, so FB will be rho of water into G into volume of fluid displaced. Okay, minus weight is given as 16.5 Newton. 16.5 Newton. So your rho G will become 9810 times some volume of fluid displaced minus 16.5. So if I talk about volume of fluid displaced, so that will be your like volume of cone up to this point only. Okay, so let's say that this is the radius small r. Okay, so from similar triangle I can or I can write that tan theta is equal to r upon 20 is equal to 20. Okay, so here like this distance will be, this distance is a 20 centimeter. Okay, 20 divided by your height, that is 30. So from here I can write my r is equal to 20 or 40 divided by 3, 40 divided by 3 centimeter. Okay, is equal to r is equal to 0.133 meter. So if I talk about the volume, so volume of fluid displaced will be given by 1 by 3 pi r square h. Okay, this is the volume of cone, so this is equal to 1 by 3 or pi by 3 times of r square is 0.133 square. H is your 20 centimeter, it is 0.2 meter. Okay, so if I solve this, so I will obtain pi divided by 3, sorry, pi divided by into 0.133 square into 0.2. So we have obtained volume is equal to your 0.0037 meter cube, and if I substitute the value here, so 0.0037 value here, so, and multiplied by 9810, this is your minus 16.5, so this value is 19.84. so tension is equal to 19.84 Newton. Okay, so this is your this will be your tension in the connecting code. Okay, so this is your next question. So spherical shell made of material with density this is placed in the water. The inner and outer radius is given as this and this. Determine the percentage of shell and total volume that will be submerged. Shell total volume that would be submerged. Okay, so first let's find the volume of a spherical shell. Spherical shell is equal to volume shell is equal to 4 by 3 pi r2 cube minus r1 cube. Okay, is equal to 4 by 3 pi times of r2 is your 6 centimeters, so 0.06 cube minus 0.05 cube. Okay, so volume of spherical shell is equal to 0.06 cube minus 0.05 cube, okay, into 4 into pi divided by 3 into 4. Okay, so this is your volume of submerged coin, that is 3.812 into 10 to the power minus 4 meter cube. Okay, so this is your volume of spherical shell. Okay, so we can say for flotation what should happen. Your for flotation we can say that buoyant force is equal to weight. Okay, so your buoyant force is equal to rho of fluid into g into volume of fluid displaced is equal to density of spherical shell into g times of volume of stainless shell. Okay, or spherical shell. So density of liquid is like we know that your liquid is water. It is mentioned here that the placed in water. So we will use it 1000. G will cancel out by G times volume of fluid displaced is equal to density of SS, that is your 1600, into volume of SS, that is your 3.812. Okay, into 1600 divided by 1000. Okay, sorry, but one more thing. Percentage of cell total volume. Okay, so let's keep it as VSS only. So from here we can find VFD by V spherical shell is equal to 1.6. Okay, so determine the percentage of the shell's total volume that would be submerged. So your so from here we can say that volume of fluid displaced is 1.6 time, or 160% of your volume of spherical shell. But if we see here, but since it is mentioned that percentage of cells total volume that will be submerged. Okay, so like it is the shell will be like this. Okay, so inner area will be your hollow inside. Okay, so hence since like if it was solid body, your volume of fluid displaced by volume of submerged, or sorry, volume of the body cannot exceed 1. Okay, it must be less than equal to 1. At equal to 1 it will be completely submerged, at less than 1 it will be floating. But since it is hollow inside, so like more than, like let's say that this is if this is the water level. Okay, so more than the, or not this, or let's say that here. Okay, even if it like fully submerged inside, so more submerged inside the water, then what will happen, that this is your volume of water is placed. But in case of volume of metal, so or radio material, so this part is removed. Okay, so hence it is value of it has a value of 1.6. Okay, but let's leave this. And what I want to mention here is that it is also percentage of total volume that would be submerged. So total volume, if we talk about percentage of cells of total volume, so like if I say, so this is your cells total volume will be your external dimension, external volume. Okay, so from using this equation, sorry, using this equation I can calculate my volume of fluid displaced will be equal to, if I substitute value of VSS here, so this value will come out to be 6.09 9 into 10 to the power minus 4 meter cube. Okay, now percentage of cells total volume that would be submerged. So this will be your volume of fluid displaced divided by volume of outer shell. outer shell. Okay, so this will be equal to volume of fluid displaced. We know this is 0.099 in terms of minus 4 divided by volume of fluid displaced will be equal to 4 by 3 pi r outer cube. So our outer is your 0.06 cube. So let's solve this. So this is 6.099 into 3 divided by 4 divided by pi, sorry, pi, okay, divided by 0.06 cube. So this comes out to be equal to your 0.674. okay, so this is equal to your 67.4%. so 67.4% of the volume is submerged, okay. I hope you get this point now. So it means that if this is your shell, let's say this is your shell, sorry, if this is a cell, outer radius is equal to 0.06 and inner radius is equal to 0.05. Okay, so your 67% area is submerged. So let's say this is your okay, sorry, let's move it into middle. Okay, so this line will indicate your 50% location. Okay, and as it will move upward, so let's say here at some point we have obtained our 67.4%. okay, so this will be our free surface of the liquid. Okay, and it will be something like this. Okay, so this is density, see, this is your shell and this is your water. Okay, so I hope you get this point now. Now we will move to our next question. So in this question it is mentioned that the volume and average density of the regular shaped bodies are determined by using a spring scale. The body weight is this Newton in air and this Newton in water. Determine the volume of the density of the body. Okay, so when we measure, how do we measure the weight? So we attach the object to a spring scale. Now we have suspended the object to this. This is your object. Now there will be two type of forces acting. First is your weight. Second is your buoyant force. Okay, and this is here your tension T in the wire. Okay, and this tension T is equal to weight minus buoyant force. Okay, now this tension T is basically your reading of the spring balance. Okay, now it is given that it is 7200 when it is weighed in your air. So your buoyant force in air is 0, is 4. Okay, and 4790 in case of your water. Okay, so let's subtract both these. So if you subtract this, so it will become here 7200 minus 7200 minus, so this is 2410 is equal to W minus W is 0. This will become FV. Okay, so this is your buoyant force. Okay, now this buoyant force is in case of your water. Okay, so 2410 is equal to rho of water into G into volume. Okay, or volume of fluid displaced, volume volume we can also say that volume of fluid displaced here. So volume of fluid displaced is equal to, if I substitute rho of it, water is equal to 1000, so divided by 9 9810. Okay, this volume displaced become 0.2456 meter cube. Okay, okay, this is volume fluid displaced, and this volume will also be equal to your like volume of the object. Okay, so it is asked that the volume and average density of the irregular shaped body you have to calculate. So your volume of body is equal to 0.2456 meter cube. Okay, this is the volume of the body. Okay, now we have to calculate a density of the body. Density of body. Okay, so we will use this equation here. So from here I can write my 7200 is equal to weight. So this is the actual weight of the body and can be written as the density of a body, density of body times of g times of volume of body. Okay, so we will inverse it and multiply it with 7200 divided by 9.81. Okay, so from here we have obtained our density of body is equal to 2987.55 kg per meter cube. Density of body is equal to 2787.55 kg per meter cube. Okay, I hope you get this. Now we will move to our next question. So in this question, a uniform rod is hinged at point B in the on the water line and is in static equilibrium as shown when 2 kg of lead. Okay, so 2 kg of lead specific gravity is given is attached at the end. When the specific gravity of the rod material, what is the specific gravity of the rod material? Uh, what is peculiar about rest angle theta is equal to 30 degree? Okay, so from this diagram we can say that the mass of the body will acting on the 2 points. First, let's say that since on this road, at midpoint of this road, your this will be your weight of road. Okay, this is your, here it will be your weight of lead. Okay, now the buoyant force acting on this will be your FB weight road. Okay, and here also the buoyant force acting will be, okay, and it is given that your diameter of the rod is your 4 centimeter. So I can write the values here. So let me write them here first. So weight of the rod is equal to your, let's say, density of the rod into g times of volume of the rod. Okay, is equal to rho of rod into g into volume is equal to pi by 4 times of d square into l. L is the length of the rod. Okay, is equal to density of rod times of right of into pi by 4 times of d square is your 4 centimeters, so is equal to 0.04 meter square into L is equal to 8. Okay, so if I solve this, 9.1881 into pi into 2 into 0.04 square. Okay, so your weight of road is equal to 0.0986 density of times of density of road. This is your Newton. Okay, now your weight of lead is equal to mg, and your mass is given as 2 kg. So 2 times of 9.81, 9.81 into 2, this is 19.62 Newton. Okay, and we can similarly also calculate your bind force acting on both rod and lead. So your FB1, FB rod is equal to rho of water. Since water is the medium here, okay, water is the medium here. So rho of water times of G times of volume of fluid displaced is equal to volume of rod here. Okay, and this is equal to, if I solve this, so G into V of rod will remain same only, and density of rod will equal 1000. So this will become 98.6 Newton. Okay, so FB for lead is equal to density of lead times of G times of volume of lead. Okay, and this would be equal to your now you have given the value of density of the lead is equal to 11400 times of G times of volume of lead. So volume of lead we don't know. Okay, but we can calculate it by using your, so let me do one thing here. Okay, sorry, I made a mistake here. This should be your density of water, okay, time volume of lead. Now density of water is written as 1000 times of G, that is 9810, into your volume of lead can be written as mass of lead upon density of lead. So volume is equal to mass of lead, that is 2 kg, divided by volume of the lead. Volume of the lead is your, sorry, divided by density of the lead, that is 11400. Okay, so if we solve this, so from here we can obtain 9810 into 2 divided by 11400, okay, is equal to a bind force due to lead is equal to 1.72 Newton. Okay, so this is a bind force due to lead, bind force due to rod. This is your weight of the rod and weight of the lead. So we have calculated all the four values. And if this angle is theta, here, so what I can say, that summation of moment about B will be equal to 0. Okay, so your moment about B can be written as your W rod minus FB rod times of, so this distance from here to here is your this distance, half distance will be 4 meter. Okay, so 4 meter cos theta, so 4 cos theta, okay, is equal to, or I can write plus W lead minus FB lead, okay, into at cos theta is equal to 0. Okay, so if I substitute the value, so this will become 0.0986 times of rho of rod, okay, minus FB rod. FB rod is 98.6, okay, plus or equal to, I can write it as FB of lead, or 2 times of FB of lead. FB of lead is your 1.72 minus your weight of lead. So weight of lead is here 19.62. Okay, and this would be equal to 19.62 minus 1.72, okay, into 2. Okay, this is negative sign, plus 98.6.0986. So from here I can write that my rho of road is equal to 636.92. Okay, so this is your density of road. So your specific gravity of road material is equal to 0.637. Okay, and since we can say next part is what is peculiar about your rest angle theta, but we can say here that theta drops out. Okay, so like theta doesn't affect, theta does not affect the solution. Okay, okay. So in this question, it is mentioned that density of the liquid is to be determined by an old 1 centimeter diameter cylindrical hydrometer whose division marks are completely wiped out. The hydrometer is first dropped into the water and then water level is marked. Okay. The hydrometer is then dropped into the other liquid. Okay, so this is marked for water, and when it is dropped in the other liquid, and it observed that the mark of the water has risen by zero point 0.3 centimeter above the liquid interface. If the height of the original water mark is 12.3 centimeter, determine the density of the liquid. So since from here we can say that in both cases your this hydrometer is floating. Okay, so I can say from principle of flotation or Archimedes principle that your buoyant force is equal to weight of the hydrometer, and weight will remain in both for both cases. Okay, so I can say that this weight will be equal to your buoyant force in water, that is rho of water g times of 12.3, that is 0.123, or let me write it h of water. H of water, and this should be further be equal to your rho of liquid, like unknown liquid, times of g times of h of liquid. Okay, so from here I can say that rho of water we know is 1000. Let's cancel out g and g. Okay, into h of water is your 12.3 centimeter. 12.3 centimeter. 12.3 is equal to density of liquid into h of liquid here is 12 centimeter into 12. Okay, now from here I can say that rho of liquid is equal to, this is your 12,300 divided by 12. This is your 1025 kg per meter cube. This is your density of the liquid. Okay, so like since the tube is dropped in both liquid, okay, same tube is dropped in both liquid, it means that weight of the your tube will remain same, and by the principle of flotation or by Archimedes principle, we can say that your buoyant force is equal to weight, and buoyant force in buoyant force in both liquids should be same. Okay, and buoyant force here rho gv, density of the fluid, times its acceleration due to gravity times your like the volume of fluid displaced. Okay, oh sorry, I forgot to like, let's say that diameter, since we know the area is equal to 1 centimeter, so we can say area A is, let's say, it is a cross section area. Okay, I forgot to like include A into H. This is volume. Okay, A into H. Now A can cancel out. Okay, I hope you get this question now. Now we will move into our next question. So in this question, so a uniform body of size 4 meter long, 2 meter wide. Okay, so let me make it 4 meter. Let's say this is 4 meter. Okay, 2 meter wide, something like this. Let's say it is something like this. Okay, okay, so let's say that this length is 4 meter and width is 2 meter, and given a depth 1 meter deeps, 1 meter deep. So depth is 1 meter. So let it say something like this. The box is uniform body is like something like this. Okay, okay, so this is the body. Now it floats into the water. What is the weight of the body if the depth of immersion is 0.4 meter? So since your depth of immersion is given as 0.6 meter, so it means that this is somewhere your water level. Okay, your this distance is 0.6 meter. Okay, and this height here is 1 meter. This distance was 2 meter, and this is your 2 meter. Okay, now it is asked determine the metacentric height also. Okay, so we have to first find weight of the weight of the body. Okay, so we can say that according to principle of flotation, or flotation principle, or Archimedes principle, we can say that, okay, principle of flotation. Okay, so from this we can say that your buoyant force is equal to weight. Okay, weight of the body. Okay, so I can write that weight is equal to your buoyant force will be equal to weight of the liquid displaced. So rho of water times of G times of volume. Volume is your 2 meter by 4 meter into 0.6. Okay, so if I substitute values here, so 2 into 4 is 8 times of 0.6, 4.8 times of 9810 for water. Okay, so I can say that weight of the body is equal to 47 point or 47,088 kg. This is your weight of the body. Now determine the metacentric height also. Okay, so as I mentioned earlier, that metacentric height is given by Bm minus Bg. Okay, and your Bm is given by I minimum upon VFD minus Bg. Now Bg is calculated geometrically. Now let me show you here how your Bg is calculated. Okay, so let me draw this face here differently. Okay, so let's say I have zoomed it out. Okay, this is your this face, and your water line is somewhere here. Let's say your water line is somewhere here. Okay, I can say that this point, like here, is your representation of your G, which is at point the half of distance. It is point, or not here. Let me write it downward side. Okay, so this distance will be your, like, since your width is 1 meter, so this will be your 0.5 meter, and this is your center of gravity. Now if I talk about your center of buoyancy, so your buoyancy will be somewhere at this place, like this is a 0.6 meter, so around 0.3 meter will be your center of buoyancy. So this is your B. Okay, so your height, this height is your 0.3 meter. Okay, so from there I can write that my BG distance is equal to 0.5 minus 0.3 is equal to 0.2 meters. Okay. Now let me write the value of I, moment of inertia, that is your minimum. Okay, so this is will be your water line area. Okay, water line area will be in this form, rectangular form only, and your minimum moment of inertia will be 4 into 2q divided by 12. Okay, now this is the I divided by the volume. Volume will be equal to, now this volume of fluid is placed, that is 4 into 2 into 0.6. Okay, minus bg is your 0.2. So if you solve this, so let's cancel out first. 4 and 4 will cancel out. Now here 8 divided by 12 divided by 2 divided by 0.6. Okay, so this minus 0.2, so this comes out to be 0.36 is equal to 0.36 meter. Okay, so this is your metacentric height. So we have calculated both your weight of the body and metacentric height. We have calculated both values here. So this is weight and this is the metacentric height, gm. Okay, now in next question, a block of wood of specific gravity pointed floats in the water. Determine the metacentric height of the block if its size is 3 meter by 2 meter by 1 meter. Okay, so it is also this system is also something like this. Okay. Okay, something like this only, but there is some change in dimension. Okay, now here this dimension is your 3 meter. Now this has a specific gravity of, that is density is equal to, this has the your specific gravity of 0.8 and it floats. Okay, so since your its density like specific gravity is less than that of water, so it will float above. Let's say that here is your like free water surface. Okay, and let's say that x is the depth of immersion. Okay, so I can write that my weight is equal to buoyant force, and this weight is equal to 0.8 rho sorry sg, or let's write rho only, into v. Now v is your 3 into 2 into 1. Okay, is equal to fv. Fv is given by 1000 into g into 3 into 2 into x. Okay, so from here we can calculate x is equal to 3 into 2 will cancel out, and g will cancel out. So this will be your 800 divided by 1000, that is 0.8 meters. Okay, it means that 0.8 meter of the wood will be submerged in the water. Okay, now determine the metacentric height for the block of this size. Okay, so metacentric height I can calculate that gm is equal to bm minus bg. Okay, I minimum upon bfd minus bg. Okay, now this I minimum is equal to bd cube by 12. So bd will be 3 times of bd cube divided by 12 into vfd. Vfd is given by 3 into 2 into x. Okay, minus bg. So if I want to calculate bg, so let's like subtract the location of g and b. Okay, so g location is here 0.5 as I have done in the previous question, minus g location is, or b location is your x by 2, that is 0.4. Okay, so if I solve this, so from here I can calculate my gm value. So let's solve this first. So let's cancel out. So 4 2 is 8, 3 8 divided by 12 divided by 2 divided by 0.8. This is 0.46 minus 0.1 if I do, so this will be 0.8. 32 meter. This is your metacentric height. Okay, this is your metacentric height of the log. Okay, now let's move to the next question. So a solid cylinder of diameter this meter has height of 2 meter. Find the metacentric height of the cylinder when it's floating in the water and with its vertical axis, the specific gravity of the cylinder is this. Okay, so it's something like this. There is a cylinder. Let me draw it here. So let's say that this is a cylinder. This is your cylinder. Okay, the cylinder has a diameter of 0.3 meters and a height of 2 meter. So it's something like in the flattened type. It is something like this. Okay, it's something like this. 3 meter and 2 meter. Okay, so 3 meter diameter. This distance is 3 meter and this distance here is your 2 meter. Now find the metacentric and have the density, specific gravity of the cylinder is S is equal to 0.7. Okay, now it's floating in the water with vertical axis. So since S is equal to 0.3, 0.7, so let's say that this is your floating surface. Okay, and X is the height of immersion. So for constant if we calculate X here, so X will become 0.7 times 2, that is 1.4 meter. So but let me write it. Okay, we can write from here that weight is equal to buoyant force. So weight is equal to 700 into G times of area of cross section times of height, that is 2 meter, is equal to your road density of water, that is 1000, times of G times of area of cross section A into X is equal to your buoyant force. So from here, if you calculate the value of X, so it will come out to be your 1.4 meter. Okay. Okay. So this is your height of the cylinder inside your water, or portion of the height of cylinder inside the water. Now if we have to find the metacentric height, so we can calculate your metacentric height by using Gm is equal to Bm minus Bg. Okay, now Bm is again I minimum upon Vfd minus Bg. If I write the value of I minimum, so I minimum for circular section is your pi by 64 into d ki power 4, and now d is 3 meters, so d ki power 4. Okay, so this is your I. Volume displaced will be pi by 4 times of d square times of x. Okay, minus Bg if we talk about. So location of G is half of this diameter, so the length height, this will be 1 minus. Okay, so your G will be somewhere here, this is your G, and this here will be your B, and this distance will be 1 minus your distance of B will be your x by 2. Okay, so if I substitute my values here, so from here I can get, let's say pi and pi will cancel out, and 64 will cancel, this will become 16. 9 divided by 16 divided by x, that is 1.4. This minus 1 plus x by 2. X by 2 is your 0.7. So this comes out to be your 0.1 meter. So this is your metacentric height Gm. Okay. Similarly, body has a cylindrical upper portion of 4 meter diameter and 2 meter deep. The lower portion is a curved one, which displaces a volume of 0.9 meter cube of water. Okay, the center of buoyancy of the curved portion is a distance of 2.1 meter below the top of the cylinder. The center of gravity of the whole body is 1.5 meter below the cylinder, sorry, below the top of the cylinder. The total displacement of the water is 4.5 tons. Find the metacentric height of the body. So it is something like this. uh, 4 meter. Okay, this diameter is 4 meter and 2 meter deep. Okay, now the lower body is curved one, so it's something like this. Let's say something like this. Okay, okay, and this portion has volume is equal, or let's say that this is your 0.9 meter cube. Okay, now the center of buoyancy of the curved portion is a distance 2.1 meter below the top of the cylinder. So it's something like this. Okay, so let's say it's something like this. Okay, now this distance is your, this is your center of buoyancy for the curved portion only. Okay, so this is b2. b2 is at your 2.1 meter. Let's say this is your body 1 and this is the body 2. Okay, so this is your v2 is equal to this. Now what else is given? The portion, from the top below, the center of buoyancy of the curved portion is a distance 2.1 meter below the top of the cylinder. Sorry, this is not v2. v2 is like this, from the top of the cylinder. Okay, so since it is from the top of the cylinder, so I can write it as your 0.1 meter. Okay, something like this. Okay, something like this. Okay, now the portion is at a distance of okay, and what else? The center of gravity of the whole body is like g of the body is 1.5 meter below the top of the surface. So this is your g. Okay, and g is at your 1.5 meter below the top of the cylinder. The displacement of water is, so volume of fluid displaced is given as, or weight of the fluid displaced. Weight of the fluid displaced is equal to 4500. This is your 4500 kg, or let's write mass of the fluid displaced. This is your 4500 kg. Okay, now find the metacenter. Again we have to find the metacenter. So from here, if I write volume of fluid displaced, so I can write it as mass upon density. So density 1000, so that will be your 4.5 meter cube. Okay, now what does this mean? This means that v2 is only 0.9 meter cube. So this portion will definitely be inside the water. Okay, now if I want to measure how much amount, let's say it is immersed in the water till this point, let's say up to this point, this is your water level. Let's say this is your water level, and let's say that this distance is x. Okay, so if I write the equation here, that is your so vft is equal to v2 plus pi by 4 times of d square. So d is 4 into height. Height is your x. Okay, this is your volume. Okay, so if you solve this, so 4.5 is equal to 0.9 plus 4 pi times of x. Okay, now if we solve this, so let's solve this. So 4.5 minus 0.9 divided by pi divided by 4. Okay, so this is, so your x is equal to 0.286 meter. Okay, so up to this point is where your water line is present, and x value is 0.286 meter. Now since we have to calculate what we have to calculate here, like first we have to calculate metacentric height. So for calculation of metacentric height, I can write gm is equal to bm minus bg, where your bm is written by I minimum upon volume of fluid displaced minus bg. Now bg needed to be calculated here manually. Okay, so to calculate bg, we should know the value of g and g and b. Okay, so we know that g at this point, and your, if we talk about b, so let's say that we have calculated overall b from this point. Let's say this is your reference line. Okay, and at a distance of, let's say y, let's say at a distance of y, you have, here is the overall b. Okay, so what I can write here, I can write that volume of fluid displaced times of y is equal to volume of the first body that it's submerged. So this part, volume of this part. Okay, this part volume will be pi by 4 into 4 square into x. This is volume, and your center of buoyancy is at 2 minus x by 2, 2 minus x by 2. Okay, so this is your, this distance, like for part 2 only. Okay, plus 0.9 into 2.1. Okay, so let's substitute the value here. So this is your pi by 4, that is pi into 4 into x, 0.286 into 2 minus 2 minus 0.286 divided by 2. Okay, so this terms comes out to be this, plus 0.9 into 2.1. Okay, and this divided by total volume, sorry, volume of fluid displaced is 4.5. so we have obtained our y is equal to 1.9 meter. Okay, now so I can say that my bg is equal to 1.9 minus 1.5 is equal to 0.4 meter. And if I substitute the values here, so here I minimum I can write it as pi by 64 into d ki power 4. D ki power 4 is 4 q to the power 4. Okay, and into vfd, that is 4.5 minus bg, that we have just calculated is 0.4. Okay, so if you solve this, your 4 4 16 4, so this will cancel out this point. Okay, so it will be 4 into pi divided by 4.5 minus 0.4. so we have obtained our gm is equal to 2.39 meters. So this is the solution of the question. I hope you get this. So a pontoon of 1500 tons displacement is okay. So our displacement is, so volume of fluid displaced is 1500 ton, and this will be equal to your weight of the pontoon. Okay, so let's say that this is a free surface. Okay, so your pontoon does have your, or this is your pontoon, let's say. Okay, and it has the your weight of 15,000 kg. Okay, 15,000 times of g. This is your weight. Okay, now what is mentioned? A weight of 20 ton is moved through a distance of 6 meter. Okay, so let's say this is your center of axis. So a mass of, let's say this is your small w is equal to 20,000 g. This Newton, okay, is moved through a distance of 6 meter through a 6 meter. Okay, across the deck of the pontoon. The tilt of pontoon through an angle of theta is equal to 5 degree. Okay, so let's say this was the original line. Okay, let's say that after tilting this will become your new location. So this is your theta. Okay, and let me draw it here. Okay, so initially let's say this was g, this was g initially, this is your g dash, and this was your initial v. Let's say this was a v and this is your final v. Let's say these points. Okay, now this is your weight, small w, and if we talk about your movement. Okay, let's take movement about your point m. So I can say that weight w acting here, w time of gm sin theta. Okay, and this will be equal to your small weight times of your x cos theta. Okay, because here let's say this is your x, this is your x. Okay, and this weight is your w, this angle is your theta. If I talk about your vertical perpendicular to this component, so this will be your w cos theta, or I can say that my x will become x cos theta. So if I solve this, so from here I will obtain my gm is equal to wx by w tan theta. Okay, is equal to, now small w value is 20,000 ton. So 20,000 time of g into x is your 6 meter divided by w tan theta, that is your w is equal to your 1,500,000 g times of tan theta. Tan theta can be written as, since it is 5 degree, so 5 degree can be written as 5 pi upon 180 radian. Okay, and since angle is small, so tan theta can be written as theta, and this will become 5 pi into 180. Okay, so if we solve this, the term will cancel out, and 5 4s are, okay, now it is 1500. So 6 2s are 12, 6 5s are 30, and 250 this will become. Now this will cancel out here. So from here you have obtained 4 into 18 divided by 25 pi. 4 into 18 divided by 25 divided by pi. So this becomes your gm is equal to 0.92 meters. This is your metacentric height. Okay, and this is basically your calculation of metacentric height using experimental method. Okay, in that we place a small weight and move it, like on tilting the small weight will move, and we calculate what should be the required, or what should be the resulting your metacentric height. Okay, now this is your last question for this session. For the time period of rolling of the solid cylinder of radius this and length this, the specific gravity of the cylinder is this, and the floating in the water with its vertical axis. So we have to calculate your time period. So we know that time period is equal to 2 pi of root k square upon g times of GM metacentric height. Okay, so we have to calculate two things here. First your radius of gyration, second is your GM. Okay, so if I want to calculate your center radius of gyration, so I can write moment of inertia is written as your a times of k square. Okay, so if your moment of inertia value is like for a cylinder or for a circle, it will be your pi by 64 d की power 4 is equal to a, that is pi by 4 d square times of k square. Okay, so from here I can write my k square is equal to so d square cancel out, and here d square will be left, here d square by 16. Okay, so this is value of k square. Now if I substitute the value of k here, so d value is here, so radius is 2.5 meters, so d diameter is 5 meter, so this is your 25 upon 16. Okay, now what I have to calculate is your GM. So we know that GM is equal to BM minus BG. So BM is I minimum, that is pi by 64 into d की power 4, that is 5 की power 4. Okay, from here we can write that diameter is equal to 5 meter, length is equal to 5 meter, uh, into volume of fluid displaced. So from here we can say that since specific gravity of cylinder is 0.9, so your like depth will be your 0.9 types of, or let me, like I can also write it here. So I can say that W is equal to FB. Okay, so 900, or I can write 0.9 times of your height is 5 meter is equal to your H here. Okay, it is amount to, so H is equal to, H is equal to 4.5 meter. Okay, so pi by 4 into d square is 5 ka square into 4.5. Okay, minus bg. Now we know that for this side your b will be h by 2. Okay, and g will be 5 by 2. So 2.5 minus your, or I can write 5 minus 4.5 divided by 2. Okay, so if I solve this, so like 5 and pi cancel out, your 5 square cancel out here, this will become 16. Okay, this is 25 divided by 16 divided by 4.5 minus, so this term will become 0.5, so 0.25, this resultant will become this. So from here I can write my GM value is equal to 0.097 meter. So this is your metacentric height. Now if you substitute these values here, so we will obtain t is equal to 2 pi times of root k square is your 25 upon 16 into 9.81 into 0.097. Okay, into 9.81 into 16. Okay, inverse into 25. Now this will become okay, into 2 into pi, sorry, divided by into pi. So this becomes t is equal to 8 seconds. This is your time period. Okay, so I hope you get this solution. Now with this we are concluding our question session 4. Thank you.